Next topic in the fifth unit of EDC is negative voltage feedback amplifiers. The need of negative voltage feedback amplifiers. An amplifier is simply an electronic device that is used to increase the strength of the input signal. In the process of amplification, even the disturbances or noise present in the signal will also get amplified. That's the reason why we use negative feedback in amplifiers. A portion of the output signal in phase opposite to the input signal is fed to the input of the amplifier, which significantly reduces the noise level in the output signal. The negative voltage feedback amplifier is represented in this block diagram. The input is given to the amplifier circuit. The portion of output is fed back to the input, which consists of the mixer terminal. In the mixing terminal, the negative terminal, the feedback is connected to the negative point of the mixing signal, that is mixer. Negative feedback amplifiers can stabilize the amplifier gain by reducing the dependence of amplifier gain on various transistor parameters or variation in the supply voltage. Negative feedback amplifier gain GVF is equal to GV voltage gain divided by 1 plus beta into GV. Here the GVF is resultant amplifier gain with negative feedback. GV is equal to amplifier gain without feedback. Beta is the feedback ratio or feedback factor, which reduces the nonlinear distortion. Here dVF is equal to D divided by 1 plus beta into GV. Here dVF is equal to resultant distortion level with negative feedback. D is the distortion level without feedback. GV is the amplifier gain without feedback. Beta is the feedback factor. Negative feedback amplifiers increases the circuit stability. The output of an amplifier without negative feedback is affected by variations in temperature, frequency or amplitude of the signal, which further changes the gain of the amplifier. We get a distorted signal in the output, hence the negative feedback is applied so that the gain of the amplifier is stabilized. The next point is which decreases output impedance or resistance. Z0 dash is equal to Z0 divided by 1 plus beta into GV. Here Z0 dash is equal to resultant output impedance with negative feedback, where Z0 is equal to output impedance without feedback. GV is equal to amplifier gain without feedback. Beta is the feedback factor. The next point is which improves the frequency response and bandwidth. The negative feedback to the amplifier is a resistive network, hence the gain of the amplifier with negative feedback is independent of signal frequency. The gain becomes constant over a wide range of signal frequencies. In this way, the frequency response of the amplifier with negative feedback is improved. The next advantage is it improves the frequency response and bandwidth. Here RD dash is equal to RD into 1 plus beta GV. RD dash is equal to resultant cutoff frequency with negative feedback. FD is equal to cutoff frequency without feedback. GV is the amplifier gain without feedback. Beta is the feedback ratio.